So this circle over here belongs to our YZ plane. This is out of plane. Okay, so this is a possible solution. Okay, so everything is inside the what? Inside the operating bracket. Okay, so we found solution number, what do you call it? Number 1. Okay, so this is our first possible value. Okay, so you realize that everything is inside the what? This is a possible solution because everything is inside the operating pink box. Okay, the operating. So the pink box is basically the U strength in terms of normal stress and also in terms of what? Shearing stress. Okay, so we have to find one more. Okay, so this is not enough. We have to allocate one more position or one more normal stress of in the Y direction. Okay, so I'll let you guys copy. Anyone, any questions so far? Right, I hope you'll find drawing Mohr circle is easier than doing, like last week I posted this, than doing this. Okay, so the solution is 56.88. Exactly the same way. So we have the stress average is 6.56, exactly that as what we have. Okay, so we constructed Mohr circle. We found that the answer is the same. Okay. Now the third circle. Okay, so what is the other possibility? Okay, so I'm going to draw Mohr circle again. Okay. Do you all need me to stay on this page longer when you copy, or we're okay? We're okay? Right. Next circle now. I'm going to copy this. Okay. So the next one, I'm just going to draw half the circle now because I only need to use half of it. Okay, I don't want to waste time now. Okay. Wrong color, come on. So we are just going to stick by the negative side. Okay, so minus 160, minus 140, minus 120, 100, 80, 60, 40, 20, 0. I'm just going to draw up to 20. Okay, positive. Then the shear. I need to do until 80. Okay. Element rotate clockwise, anti-clockwise. 20, 40, 60, 80, minus 20, minus 40, minus 60, minus 80. Okay. Then I'm going to draw the box. I'm going to draw the box. And it was pink in color, right? Okay. So the box was at 75. Okay, so this is the box where we cannot go out. Okay, once we are out there, the material will fail. I only draw half. I don't want to waste time to draw the other half up to positive 150. So again, you will see that this is 75. This is at minus 150. Okay, in the vertical, the horizontal on the shear is at 75. Okay, then we still have our regular 70. A regular 70 point. And then we have our 40. Okay. So this is our point. We already know that this is our point. X, and this is our point Z. Okay. So what is the other possibility? Okay, so the other possibility is where we use the stress mean value at -1. So I'm going to join a line from here to here using stress mean. Okay. So we know that this is our minimum stress. It cannot be any lower than that. Okay. Then we are going to find, I'm going to copy this, and I'm going to paste, and I'm going to rotate by 90 degrees. Okay. I'm going to rotate by 90 degrees. Okay, so this is our first circle, right? So some of you will ask me, what am I doing down here? Yes or no? Right, Eugene, what are we trying to do over here? Okay. Why are we drawing triangles like that now? Yes or no? Okay. So let's step aside and let's look at the rules of the rules of a circle. And I want you all to do this. Those of you who are online, try to do this, okay? And those of you who are here, try to draw this also, like what I'm drawing now. Only when you draw, you appreciate what is going on, okay? So what I will suggest that we do is we draw a circle, okay? We draw a circle. We draw a circle. Okay, so this is a circle that we draw. Don't worry about dimension. I'm going to stretch it a bit more. Okay, this is our circle. And we are going to identify the center of our circle. So this is the center of my circle. Okay, so likewise, when you draw, you have a center of circle. Okay. So from here, I want you to draw a line in any orientation that passes the center of the circle like this. Okay. And when it crosses the center of the circle, you call it our point O. Okay, that is our point O. And then when one end it touches one of the circle, the perimeter of the circle, we call it point A. The other end, we call it point B. Okay. Right. From here, I'm going to pick a point, any point that you want to pick. Okay. So I'm going to pick a point over here and over here, and this is known as my point C. Okay. That is my point C. So now when I join point A to point C, right? And then I join point C to point B, right? What you realize down here, let me be more precise. Today my eyes is a bit blurry. I'm getting blind. Okay, so that position over there at angle LCB, this is 90 degrees. Okay, that's 90 degrees. So how to prove it's 90 degrees? So if I use the software, I copy and I paste this line, right? And then if I rotate this line by 90 degrees, as you can see now, it's exactly the same orientation. Can you see that? Right? We can pick another point, okay? If you are like doubtful, it's okay. I can pick another point, and I pick another point over here. If we pick another point over here, we call it our point D. Okay. So likewise, the same thing. I'm going to draw lines from A to D, right? D to B. Stupid location. But anyway, it's a random point that I pick. Again, I copy and paste, and then I rotate it by 90 degrees. Right? It is 90 degrees. Okay? Right? So this is also 90 degrees. Now, going back to Mohr circle, this is where I decide to construct 90 degrees over here. Can you see that now? That is the only reason for that. Okay. So we know that this is one of the circle. I repeat again, we know that this is one of the circle. Okay. So I'm going to calculate what is our stress A. Okay. Why I need to calculate our stress A, right? So only if I calculate stress A, right, then I can construct a Mohr circle. Then after constructing the Mohr circle, I can find the stress average, then I can find stress 2. Okay. So I'm going to call this point over here alpha. So this is also equal to alpha, right? So from here, we can find what is our tangent alpha. So tangent alpha is 40 divided by 10, 20, 30, 40, 50, 60, 70, 80. Okay. So alpha is equal to 10, 20, 30, 40, 50, 60, 70, 80. Yep. So 40 divided by 80 inverse tangent is equal to 26.6 degrees. Okay, that is 26.6 degrees. So from here, I can find our stress A. Right, so stress A is equal to minus 70 plus, right, so let me do some side work. So tangent alpha is equal to x over y. So I want to find x. So it's equal to 40 tangent 26.6. So tangent 26.6 times 40 minus 70. So it's equal to minus 50. Okay, minus 50 megapascal. So from here, we can draw one of our circle. So this is 5. So this is our data circle. Okay. So we can also calculate our stress average. Okay. So stress average is equal to minus 50 plus by minus 150 divided by 2 is equal to minus 100. Okay. So this is where our stress average is. Right. So this is our stress average. Okay. Then we can draw a line from here across the center and come to here. Okay. Why do we use 40 and 80 when calculating? So 40 is because of the distance from here to here. Let me do outside. Okay, so this is our 40. And then the distance from here to here. Not here to here, from here to here. Okay, so that is our 80. 2, 4. Yep, here is our 80. Okay, Jihan, is it okay? Okay, right. So now this is our stress Y2, right? So if you look at stress Y2, we have to determine our stress Y2. Okay. So how are we going to do that? Okay. Now let's go back to the rules of the circle. Okay. Let's look at the right hand side. So based on the rules of the circle, okay, if I draw from point C to the center of the circle, and if I call this alpha, right, this is also equal to alpha, right? Because the radius are the same. So this angle over here is 180 minus 2 alpha.